This is where I can actually specify how I want the data stored in the data warehouse. So up until now, it's been sort of a logical view of my data. Nothing's actually been stored in the data warehouse. So this is just keeping information about the data. So the first thing is the name of the destination table. If you had multiple clusters, for example, if you could have a dev, test, and a production cluster, you'd choose which cluster to make this go to. There's only one, so I'm going to leave it there. The schema is what was discovered. So now you can see there's each of the columns that were inside the JSON can be removed and taken out as their own. So for example, I could choose to take out client version, device parameters, and these are sort of nested JSON inside of JSON, right? So I'm gonna just keep most of the data as is. Because I don't really understand it. I want to discover the data first. And so I'm going to just load the entire JSON as a single column. And then I'll show you how to manipulate it. Table structure is sort of kind of an important thing as you think about how you model it. In this particular case, I'm going row store and random, but columnar store is also available. And you can choose hash, range. Random is sort of a distributed, so it'll just try to distribute data evenly across all the disk volumes that are available. Hash is a similar structure, but hash will look at something that's a unique column. So things that are primary keys, things that have a lot of unique values are good good columns for hash partitioning. Generally, user ID, product ID, anything that's an ID is a good sort of candidate for hash partitioning. And range is range. Generally, if your data comes in on a time schedule, you want to use time as a partitioning scheme. The idea being, you want to chunk your data up into individual partitions, and that will make it faster to retrieve, faster to query. If you're always going to use kind of a time range to query your data, then you want to do a time-based partition. The next one is, we talked about sort of the ELT concept. So this is where you can actually do what we call a simplified workflow. So it's a preload step that occurs. For example, you might want to set certain parameters at the start of the load. And then data gets loaded, and then there's a post-load step. And the post-load could be generate an aggregate, count certain things, go build another table after this is loaded, so on and so forth. Go update things. We see a lot of people do this post-load step, particularly in JSON, where they're looking at generating today's record of something, right? So they'll do sort of a post-load, go off and update a second table.
A big benefit of having a data pipeline run within the warehouse is that you can use SQL or even your user-defined functions as a step or within the steps. You don't need to know another programming language like Java. Secondly, because you're using the database's parallel architecture, your transforms get speeded up, meaning they work in bulk on the entire data being loaded instead of record by record. So this speeds up your pipeline processing as well.
Load schedule, there's two ways. So again, if this was a recurring load, you could set up a recurring time schedule for it. And you can say, load every day, starting at 12 a.m. Allowed overruns is if your data is late or it takes longer than your time interval to load data, we'll flag it, but it will allow you to continue running the pipeline. The idea behind this is sometimes you have transient timing issues, but if this continuously fails, for example, 3 times in a row or 5 times in a row, then there's something wrong with the way you set up your schedule, so we'll stop the pipeline. The thing about this one-time load is if you have historical data that you want to load in one shot and it's laid out again in a daily increment, you can give a start date and a end date and just load the entire thing in one go. So this is good for sort of looking at archived or historical data as well. So I'm going to go ahead and load it. And this will go through a bunch of steps about initializing the data, reading the bucket, loading it in an external table, and then loading in the internal table. Um, this will go pretty fast because it's we're loading everything as one shot in one column. Um, and then again, as I said, you can always monitor what's happening right from this sort of main screen. You can also abort it. Make a copy just allows you to copy all the definitions that you've just done on that and modify it and sort of create multiple loads. So again, useful if you're doing debugging, useful if you're doing dev versus production. You've set it all up here, so you don't have to recopy your pipeline.
And that's it. Your data is loaded and ready for analysis.